Alright, as promised, I said we would learn how to graph using slope-intercept form. So in a previous video, you learned how to graph equations when they're in this form, ax plus by equals c. An example would be negative 2x plus 3y equals 12. We could identify the x-intercept and the y-intercept, plot those 2 points, and then connect them with a line. So that is the process we use when it's in this form with the x and y terms on the same side. But when we come across an equation in y equals mx plus b form, when the equations solve for y on one side, and then we have the slope times x plus a y-intercept on the other side, this next method is going to be much easier to use. So we have some steps for this graphing process. The first thing you need to do is identify the slope and the y-intercept. So know where they are in the equation, and we just practiced that. So you're going to start by placing a point on graph paper in a 4-quadrant grid where the y-intercept is. So for the equation that we just finished, you can just watch this part. You don't need to write anything down. I'm just going to use one of the equations we just used in the last video. We were looking at y equals, let's see, we had negative 4x plus 9. So again, you can just watch this one. You do not need to write it down. Alright, if I want to graph this equation, I'm going to identify my slope, there it is, and my y-intercept. I'm going to draw myself a 4-quadrant grid, and in this case, since I know my y-intercept is 9, I've got to make it kind of tall, because I know that I need to get to at least 9 on my y-axis. So let's stretch this out a little bit more. Okay? Alright, so if I know the y-intercept is 9, that means the graph goes through the point 0, 9. So I'm going to plot that point, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my y-intercept. Now all I have to do is use the slope to put more points on the graph. Because remember what the slope does. It determines the steepness of the line, and it is rise over run. So the slope for this equation, being negative 4, means that it drops, it doesn't rise, it drops 4 every time it runs 1. I can always put a number 1 underneath an integer slope that's not already a fraction. So from this point that I plotted, this y-intercept, I'm going to drop 1, 2, 3, 4 units and run 1 to the right. We always run to the right. Sometimes we rise if it's a positive increase, and sometimes we drop, but we always run to the right. And once I do that, I put a point. So again, I start at the y-intercept, and I dropped 1, 2, 3, 4 units to represent the negative 4 on top, and then I ran 1 space or 1 unit to the right and put a point. Now if we do that again, drop 1, 2, 3, 4 from the last point and run 1, I get another point. And I can do this incessantly. 1, 2, 3, 4 and run 1. But I only need to do it a few times in order to get a nice straight line when I grab my ruler. So I connect my points with a straight line, and these are all the points and on into infinity in both directions that work in this equation. Alright, the next one you're going to want to write down, and this is the example on your notes page. This one's a little bit different, but it's the same idea. So number 1, in your equation, identify the slope and the y-intercept. So my slope is the coefficient of x, the number multiplied by x. So my slope is negative 2 over 3. My y-intercept is 4. So I write the point 0, 4. Alright, so step 1 was start by placing a point at the y-intercept 0, b, whatever that b value was, and it was 4. So on our grid, let's count up from the x-axis, 1, 2, 3, 4. There's our point 4, 0, our y-intercept. Alright, now we use our slope, and it's decreasing, it's negative, so we are going to drop 2 and run 1. Remember the top note in the ratio is how much we rise or drop. We drop if it's negative, we rise if it's positive, and the bottom number is how much we run to the right. So from the y-intercept, I drop down 2 units, and then I run 1, 2, 3 to the right, and I put a point. From that point that I placed, I do it again. I drop 1, 2 for the number on top, and then I run to the right, 1, 2, 3. Now if you're doing these right, these points should be in line with each other. If you run out of room in one direction, you can always reverse those steps to put points on the other side of your y-intercept. So instead of dropping 2, if I rise 2 and run 1, 2, 3 to the left, I'll get a point in line with it on the other side of the y-intercept. Once you have 3 or 4 points, grab your ruler. If they're not in line, you've done something wrong, and I think I am off a little bit. Or is my grid off? Looks like my grid is off a little bit. And connect them with a straight line. And there you have it. The graph of an equation that's in slope-intercept form